Okay, so I guess this is our fourth video on direct, inverse, and combined variations. I hope you at least watched the first two, which were how to set these kind of problems up, actually how to set up the equations and find the k values, and how to recognize what inverse and direct variations look like. Before you did this, if you haven't, you might want to consider going back and doing that now. Anyway, let's do this problem. This is, I think, number 13 from your book. And the problem is a liquid pressure problem. It says the pressure P acting on a point in a liquid is directly proportional to the distance d from the surface of the liquid to the point. And then this is a four-part question. Part A asks us to express P as a function of d by means of a formula that involves a constant of proportionality k. Some of you, when we talked in class today, you went right to it, but for me, I just always want to remind myself that this is what a direct variation looks like in general, and that so the value before the word proportional is the y value. So I'm like, okay, this is y here. So when I do my rewrite, it would look like this, wouldn't it? It would look like this. So in this specific case, this function looks like P, the pressure, is equal to K times D, where D is distance. And that's all they're asking for here, so that was a really easy part. So here's that more specific form. And then the second part is actually just the next natural part that you would do here. So it says here, in a certain oil tank, the pressure of at a depth of 2 feet is 118 pounds per square foot. Find the value of K in part A. So what I'm going to do is with part A is I'm going to remind myself that P is equal to K times D, right? And then I'm going to just substitute in values. It says the pressure at 2 feet is, so the pressure is 118, isn't it? So the pressure is 118. Oops, that's not 118. Is 118 times the depth of 2, so it would be K2. I'm going to write it as 2K here, right? And now we're going to just do a little bit of quick algebra, and we find out that K is equal to 59. It doesn't ask us to do this in this part of the problem, but what I'm going to do, frankly, is because we have this K value, and look, this K value right up here is this K value right here. So I'm just going to do a little bit of substitution and then find our specific formula that we're going to be using today is that the pressure is equal to 59 D. And this is really, really helpful. I can't over dramatize the fact that this is really what you're looking for in general, because this is what helps us do the rest of these problems. You're going to see this a lot in chemistry and in bio, especially the AP parts of that. So this says find the pressure at a depth of 5 feet. So we want to find P pressure. So we want to find P. Oops. We want to find P. We want to find P pressure. So we want to find our pressure here, P. And the pressure is equal to, I'm just going to use the equation, 59, or maybe this, P is equal to 59, right? And we have a depth of 5 feet, so depth of, 5 feet here. This is depth right here, so times 5, and that the pressure would be, so the pressure here is equal to 295 pounds per square, this is LB per square foot, I think is the right answer there, isn't it? Okay, so then this is actually going really, really quick. If you're getting this really well, terrific. If not, slow the video down, pause, and see if you can figure out what we're doing here. So far, I feel like what we're doing is just filling in the blanks. Here, it says sketch the graph of a relation between pressure and distance, pressure and depth. For depth is greater than or equal to 0, and of course depth is a distance, so it has to be greater than or equal to 0. So we put in our Cartesian plane really quickly. I'm not going to put in all of it. I'm going to just put in this part here, I think, and this part here. So we're really just looking at quadrant 1, I believe, aren't we? Then we're going to graph our function. And all I'm going to do is I'm going to graph this. I'm going to graph that pressure equals 59 times D. Remember that I said to you that I believe this is y equals 59x. So for values greater than or equal to 0, so you need 2 points. The point 0, 0 is a terrific point to use, and we know this thing is this way. I know this looks like more like y equals x. I'm sorry that it's not in proportion, but you just have to take my word for it. That here I'll tell you, not to scale. How's that? And then I'm going to just come up with maybe one other point. Let's say if we had a depth of 2, and 2 times this would be 118, wouldn't it? So just maybe 118, 118. So we have the point 2, 118. So, and this is the graph of P equals 59D. I think this actually went really well. I hope it's making sense to you. Again, the more we do of these, the easier it's going to get. And I just want to remind you that when we first started talking about this, before we learned how to do any of this, it was really, really difficult. Now I think we have our pieces put together, and now it's going to take some patience, and it's going to take a really good algorithm on your part. What do you do first? Then what? Then what? Then what? Then what? Because when you see this in chemistry and bio and physics, they're not going to give you these A, B, C, D steps. They're going to say probably just going to give you the information that they gave you in the very beginning, and then give you C and D to accomplish. So that's, I think, most likely what the real life application of this looks like.